Good evening, Lamai. Right, let's start the class, and this is going to be a small section, right? This is regarding the acid-base reactions, right? So here we are going to discuss about how to first of all how to complete an acid-base reaction. That means how to write the products of an acid-base reaction. Then how to balance the stuff, how to balance this kind of a reaction, and then we will use that knowledge we had gathered like that to solve some chemical calculation related questions, actually related to acid base reactions, right? Okay, let's start with acids and bases. What are these acids and what are the bases, right? Okay, so in small ages we have learned the chemical species which release H pluses to aqueous solutions are referred to as acids. So acids are the ones which will release H pluses to aqueous solutions. Those are acids. Like that, species which release or which provide, right, OH minus ions, oxides to aqueous solutions. Let's say oxides to aqueous solutions are referred to as bases, right? So which leads OH minus O oxides to the aqueous solutions are known as bases. Those are acids and bases, right? So if you need some examples, if you think of some examples here, examples for acids. So HCl, HNO3, no? The HCl release H plus. This H plus to the aqueous solution. HNO3 will also release H plus. So H2SO4, H3PO4. These are acids, right? So H2SO3. We can write various kind of acids. H2S. Numbers of acids are there, right? These are some examples, right? So for some bases, NaOH, KOH, like magnesium hydroxide, aluminium hydroxides. So basically metal hydroxides. Can act as bases as well as metal oxides, sodium oxide, potassium oxide, right? Magnesium oxide as well. So metal oxides, right, can act as bases. Calcium oxide, right? So metal hydroxides and metal oxides can act as bases, right? These are the acids and bases, right? Simple acids and bases, right? Okay, let's discuss more, right? Let's discuss more about this stuff, right? So you know the stuff, right? Acids and bases, the definitions are known from your small ages, right? Okay, let's discuss how to balance an acid-base reaction, right? Let's start with that, right? Balancing acid-base reactions, right? Balancing. Acid-base reactions. So, right, we'll follow 3 steps there along. We'll follow 3 steps in balancing acid-base reactions, right? Okay, let's come up with an example, and I'll explain the stuff for you. Right, there's an example, right? Let's use this one as example. Let's try to balance this reaction. Barium, sorry, H2SO4 with aluminium hydroxide. That is the example appearing in your note, right? H2SO4 with aluminium hydroxide. Right? Let's try to balance this reaction. Right? Okay. 3 steps are there. Let's try to balance. Right, with use of those steps. Right? Step 1. Step 1 of balancing this stuff. Step 1 is write in the salt and H2O. Write in the salt and H2O. Right? Writing salt and H2O as products. Right? So let's write them. So how to write the salt here? How to write the salt here? First of all, identify the ions with the acid and the base. So here 2 of H plus and SO4 2 minus. Those are 2 ions. Here the 2 ions are Al3 plus, see, Al3 plus and OH minus. 3 of OH minus guys are there. 3 of OH minus Al3 plus. So salt will be produced by, right? Salt will be produced by the cation of the base and the anion of the acid. The part other than the OH minus and the part other than the H plus will be connected as the salt. The H plus and the OH minus will be connected as water, right? As water, right? So salt and water. That is how the things appear, no? Right? So here the salt is then aluminium sulfate, right? So exchange the valencies to come up with the correct chemical formula. Aluminium is aluminium 3 plus, so that 3 comes here. Aluminium 3 plus. SO4 2 minus. SO4 2 minus 2 comes here. It's the salt, right? And water, right? Those are the products of an acid-base reaction. Step 2. Next thing is actually balancing the acid and the base by looking at the salt. Balancing acid and base, considering the salt, right? Let's do the stuff. So up to now the thing is balanced. Right? By looking at the salt, we need to balance the acid and the base. Right? With the salt, you have 2 of aluminium ions. So that you have to put 2 here, as 2 is appearing. And you have 3 of sulfate ions. 3 of sulfate ions. See? 3 of sulfate ions. So you need to copy 3 here to provide the 3 sulfate ions. That is how we are supposed to balance the acid and base by looking at the salt. Right? Step 3. Step 3. That is balancing water. Balancing water. Right? By considering the stoichiometries of acid and base. right? Okay, let's balance stuff in. So 3 of H2SO4 is there and 2 of aluminium hydroxide will provide you Al2SO4 thrice and H2O, right? Up now the things are balanced. So now it's time to balance the H2O. So here you have 6 of H pluses. You have 6 of H pluses here. 4. Yes, you have 6 hydrogens here as H pluses, as hydrogen comes up as H pluses in acids. You have 6 of OH minuses here. The OH minus part comes as OH minus in bases, right? So 6 of H pluses and 6 of OH minuses will combine to form 6 of H2Os. 6 of H2Os, right? So should have 6 here. Should have 6 here. Right now? So balance H2O by considering the H pluses and the OH minus released by the acid and base. That is a simple idea. Right? Okay. So that is how we are supposed to balance an acid-base reaction. So this is the balance acid-base reaction for the reaction between the H2SO4 and aluminum hydroxide. Right now? Clear now? Right. Let's come up with another example. Actually, here this one is kind of an example where you had used some metal hydroxide as your base, and we'll do another example using the metal oxide as the base, right? Let's do some another one, right? Okay, let's do the example 2. Next example. So let's balance the reaction between H3PO4 and the magnesium oxide. This reaction, it's another acid-base reaction. Acid and a base are to be reacted, right? Let's do the stuff here, one step by step. Step 1 again. Step 1 is related to write in the salt and water as products, right? Water as products, right? Let's do the stuff. So you have the H3PO4 and the magnesium oxide. So H3PO4 means there you have H pluses and the PO4 3 minus ions. PO4 3 minus, no? This is a charge, no? Right? 3 of H pluses and PO4 3 minus ion. Here the Mg2 plus and O2 minus, the oxide, no? You don't see any numbers appearing because the O2 minus, the 2 should be the charge with the magnesium as well. This is how the charges will cancel off, no? Those are the 2 guys, right? So how to come up with the salt? Salt means the part other than the H plus and the part other than the OH minus or the O2 minus, right? Those 2 ions will combine to give the salt. So it is going to be magnesium phosphate. Magnesium phosphate, how to write that stuff? Magnesium's valency should be written with the phosphate, Mg2 plus. Phosphate's valency should be written with the magnesium. PO4 3 minus, no? So there should be 3 here. Salt and water. Salt and water. So the H pluses and O2 minuses will connect to give you water, right? Actually, these are ion exchange reactions. Acid-base reactions are normally ion exchange reactions, right? Okay, no? Right. Let's come up with step 2. Step 2. Step 2 is actually balancing the acid and base by looking at the salt, right? So balancing acid and base right? According to salt, according to the salt. See, so you have H3BO4, magnesium oxide. Salt is written as magnesium phosphate plus water. So with the salt, you have 3 of magnesium ions, so you have to come up with 3 here, and 2 of phosphate ions, so you have to come up with 2 here, right? That is how we are supposed to balance the acid and the base with the use of salt, right? Step number 3, it is regarding the balancing water. Balancing water, actually using the H pluses and O2 minuses or OH minuses, so O2 minuses in this case, given by acid and the base. Right? So you have 2 of H3BO4 here, plus 3 of magnesium oxide, giving you the magnesium phosphate plus water. So here, so you have 6 of H plus ions, you have 6 of H plus ions, and here you have 3 of O2 minus ions. The ions are to be considered O2 minus, 3 of O2 minuses, and H pluses, 6 of those. So 6 of H pluses and 3 of O2 minuses will give you 3 of H2, will give you 3 of H2s, right? So 3 of oxygens, only 3 oxygens are appearing, 3 of H2s, right? So that is your balanced chemical reaction for the reaction between the H3PO4 and magnesium oxide, right? Things are clear, okay? Right. Okay. Let's use this knowledge we have just gathered to do a chemical calculation question related to the acid-base reactions. Okay, let's try to solve this one. Right, this is a problem related to the acid-base reactions, right? So let's try to solve this problem. Right. So first thing to do is actually we need to identify the goal. Identifying the goal is the first thing, right? And coming up with X moles, Y moles, those things with the related chemicals, right? Let's identify the goal. So basically, with the first sentence or the final sentence, right, we could see the goal appearing. So here it is the finding out the mass percentage of KOH. Finding out the mass percentage of KOH. That is the goal, no? So finding out the mass percentage of KOH and calcium hydroxide. That is the goal, right? In the sample. So the two related chemicals in your goal are the KOH and the calcium hydroxide, right? Let's take the two values as X and Y moles. Always we are coming up with moles, right? Always the unknowns are as moles, right? So let's write that thing. Let KOH amount equals X moles and calcium hydroxide amount equals Y moles. If you are able to come up with these numbers, right, then you can relate their molar weight to come up with grams, and then you are done. The mass percentage can be calculated with use of those grams, right? So X moles and Y moles, those actually in, right, 2.04 grams of sample, right? So I define the goal, that is done. Okay, Second step. Second step is actually coming up with the correct balanced chemical equations related to the procedure, right? Okay, let's come up with those, right? So here, what are the important balanced chemical reactions here? So basically it says, right? So what they have done, the KOH and the calcium hydroxide, that thing was reacted with HCl. So it's like this, no? So you had a solution with KOH as well as calcium hydroxide, right? Now you have X moles here, Y moles here. So, right, to totally react with these things, right? Totally react with these things, right? So this is a sample, right? 2.04 grams, no? To totally react with this thing, they added some HCl. So 1 mole solution, 50 cubic centimeters, right? That is the picture, right? So let's come up with the related equations. Here the HCl will react with the KOH, it's acid-base reaction, as well as HCl will react with the calcium hydroxide as well. So the first reaction, HCl reacting with KOH. The second reaction is HCl reacting with calcium hydroxide. Those are the two related reactions, right? So let's balance the stuff. HCl, KOH. First write the salt and H2O as products. So the salt is, here the Cl minus is there, here K plus is there. So KCl plus H2O. Here it is balanced, and here the salt is Cl minus is there, Ca2 plus is there, Ca2 plus is there. So the salt is CaCl2, Ca2 plus Cl minus plus H2O. You need to balance the stuff more, right? Then with the use of salt, you have to balance acid and base. So 2 of chlorines are there, so 2 should be here. Balancing water, 2 of H pluses, 2 of OH minuses will give you 2 of H2O. No? The balance, right? Okay, come up with the right correct balanced chemical equations, right? Done. Third step is coming up with the simultaneous equations. So basically you have two unknowns to solve, so you need to come up with two simultaneous equations. So you have to identify the data points to come up with those simultaneous equations, right? What are the data points here, right? So basically data points are the ones which we completely know about the chemicals appearing in there, which we completely know the chemical formulas of chemicals appearing there with that those numbers. Such numbers can be used as data points to come up with the simultaneous equations, right? So we have such two numbers, right? So here the mass of the sample, so we completely know about the chemicals, we completely know the chemical formulas of the chemicals appearing there, the KOH and COH2 related to this number. So that can be taken as a data point, right? So other data point is actually this thing, see this number, that is related to HCl. So CV data, so that will give you the amount of HCl, it will give you the amount of HCl in moles, right? Two data points. Let's write the two stuff, right? The first data point is for mass of sample, so in grams. So you have X moles of this one, Y mole of this one. So mass of sample means the mass of KOH plus the mass of calcium hydroxide, that is equal to this number 2.04. So to come up with the mass of KOH, first you need to relate these X moles with its G mole minus 1 value. The X moles into its G mole minus 1 value will give you the mass of KOH. The Y moles into this guy's G mole minus 1 value will give you the number of moles of calcium hydroxide in terms of Y. Let's write that two guys, right? So first of all, then we need to come up with the G mole minus 1 values, right? For the KOH, it is going to be This is 39, a 40 and 56. For the calcium hydroxide is 40. You have 16, 17, 54, 70, sorry, 17, 2 is 34, 34 and 40 is 74, no? 40 and, yeah, 2 of 34, yeah, 74. So then we can come up with the mass of the sample, right? So 56 is G minus 1 value, X number of moles are there. So if you have to multiply these two guys, it will give you the mass of KOH, right? So it is 56 grams, 56 X grams, sorry, 60 X grams, 56 G mole minus 1 into X moles. So mole things will cancel off. It will give you 56 X grams plus the calcium hydroxide mass is going to be like that, 74 Y grams, right? That will be equal to the number here, the data point, 2.04, number 1. This is the first simultaneous equation, right? Okay. Let's come up with the second simultaneous equation, right? The second one. So we need two simultaneous equations for, to complete solve for two unknowns, right? Second simultaneous equation. So that can be written for the moles of HCl. The constraint and volume data are given, so that we can write the second simultaneous equation for moles of HCl. Right? So moles of HCl, right? In terms of X and Y, first of all, at the left hand side of the equal side, the number should be in terms of X and Y, and at the right hand side, the data point. That is it, no? So in terms of X and Y, so you have X moles of this thing, so that you need X moles of HCl as well. X moles of HCl as well, sorry, 1:1 ratio. You have Y moles of this thing, so you need 2 Y moles of HCl to completely react with the calcium hydroxide there. As 1:2 ratio is there. Y moles means 2 Y moles. So the total number of HCl related to this process is X plus 2Y, no? X plus 2Y. So moles of HCl is X plus 2Y. That is equal to the moles of HCl, right? So we can write that HCl moles, that is equal to 1 moles per decimeter cube into 15 into minus 3, no? In decimeter cubes. That is 0.05 moles, no? So that is the number of moles of HCl, right? Okay, that is the second simultaneous equation, right? So now we need to solve for these two guys, right? Let's solve for the two simultaneous equation to come up with X and Y, right? Let's write it here. Okay, I'll write it here. Solving for X and Y, right? Let's solve for X and Y, right? Solving for X and Y. What we can do? So basically we can multiply this thing with 56 to get rid of X, right? Let's do that stuff, right? Multiply this thing with 56, right? Okay, so 2 multiplied by 56 minus 1, that will get rid of X. 56X minus 56X is will cancel off the X, right? With this mathematical operation, only Y will remain. So you have the 56 into 2 is actually 112Y minus, here you have 74Y, that will be equal to this into 56, 0.05 into 56, right? Let's do the stuff, right? 0.05 into 56 will give you the value as 2.8. That minus this value 2.04. That will give you some value as 38y is equal to 0.76. So y is equal to what? 0.02. So we can apply that value to here to come up with x. So x is equal to 0.05 minus 2y. Minus 2y is 0.04. So x is equal to 0.01. Right? Now, finally, we need to come up with the mass percentages, right? Let's do the stuff for the mass percentages, right? So, mass percentages, right? So, first, let's come up with the KOH. So, KOH mass is equal to number of moles is 0.01. The G mole minus 1 data for the KOH is 56. So, the KOH mass is 0.56 grams. The percentage of KOH is then equal to 0.56 grams divided by the total mass. The total mass is what? Total mass is 2.04 into 100. That will give you a value like 0.56 divided by 2.04. No? That is 27.45 as a percentage. Right? So if you need the same percentage for the calcium hydroxide, it is also can be calculated like that. So the number of moles is 0.02. Calcium hydroxide G mole minus 1 value is 74. So the mass is then going to be 1.48 grams, right? So the percentage is then going to be 1.48 grams divided by the total mass 2.04 into 100, right? So that value is going to be 72.5, right? So that is how you're supposed to solve this kind of a problem, right? Now, so you can copy the stuff, right? Right now, okay. Actually, this is all for today, right? This is some example calculation regarding the acid-base reactions, right? So this is how we are supposed to use these reactions in chemical calculations, right? So we'll wind up for today's lesson, right? We'll meet with the next stuff, right? Basically with the precipitation reactions and the redox reactions next week onwards. Until then, goodbye.